This one is example 1.2 from the textbook, and it says that we have a circuit element with two terminals, and there's basically nothing happening, no charge, no current, no voltage for times less than t equals 0. But then at t equals 0, the circuit switches on, and we have a 5 amp current that begins to flow into the upper terminal. So I've labeled that here with this purple arrow. So this current, we could actually sketch the kind of shape of the function. So the current here, I of t, as a function of time, starts off as 0 and then turns on to some fixed value of 5 amps. So that's 5 amps there. It turns on at t equals 0. And so we're asked to solve for an expression to calculate the charge that accumulates in the upper terminal. So basically the current is flowing in, but no current is flowing out. Well, that means that the charge must be going somewhere, and so this charge will be accumulating inside of this box. So what we can do to calculate that is we recognize that the charge accumulating here, must be the integral of the current coming in. So the other way that you can think of this is I've got this amount of current flowing in. I want to know what's the total amount of charge. Remember, amps, unit for current, is coulombs per second. So we'll make a little note here. Remember, 1 amp equals 1 coulomb of charge per second. So the area under this curve, given that time is measured in seconds, so the area under this curve must have units of charge. So area has units of coulombs. So the charge that is accumulating, let's call it letter Q. Q is commonly used for charge. So that will be the integral, basically from the beginning, turns on at 0, up to some arbitrary time t, the integral of the current with respect to time. Now the current in this case is just 5 amps. So we just have, we have the upper limit of that integral should be t. So we have integral 0 to t of just 5, which will be, of course, 5t taken over these limits 0 to t. So we will just get 5t as the answer, and that will be in units of coulombs. So this is part A, derive an expression for the charge that's accumulating. And then part B says if the current is stopped after 10 seconds, then how much charge has accumulated? So part B, what we would do is simply take our expression from before and we evaluate that at 10 seconds. So that would just be 5 times 10 is 50 coulombs of charge.